Alright guys, so we're moving on to our next lessons. We're going to slowly stray away from the triangle segments and triangles in general. We're going to move on to what we call polygons. So polygons is a polygon is a closed plane figure with at least 3 sides. So we already know if it has 3 sides, it is called a triangle. Oops. Okay, so right here I'm going to write triangle. Okay, if it has 4 sides, and everybody wants to say square or rectangle, but if it has 4 sides, more specifically, a 4-sided figure is a quadrilateral, because quad means 4. So we have different kinds of quadrilaterals, special quadrilaterals. So we are just, the most basic name is, or general name is a quadrilateral, okay? If it has 5 sides, a 5-sided figure is called a pentagon. So it's going to take you back to elementary school where you learned all these names, or at least I hope you learned all these names. If it has 6 sides, a 6-sided figure is going to be called a hexagon. Hexagon. Okay. A 7-sided figure. So if it has 7 sides, this one actually has 2 names. It's either a septagon, but it's also, you might also see it as a heptagon. Heptagon. Okay, so for some reason this one has 2 names, septa and hepta. Okay, 8-sided. So 8-sided figure is an octagon. Okay, the 9-sided figure is a nonagon. A 10-sided figure is going to be a decagon. Deca means 10, decagon. A 12-sided figure, do means 2, so do, and then deca means 10, so 2 plus 10 gives you 12, so dodecagon. And then anything after that is called an n-gon. Okay, so if it has if it has 13 sides, it'll be a 13-gon. If it has 15 sides, it'll be a 15-gon. If it has 175 sides, it'll be called a 175-gon. Okay, so here it says the following figure illustrates parts of a polygon. So we have something called vertices. So vertices are the ends, the tips here. So these are called vertices. Okay, and then we have something called diagonals. So diagonals is segments that join 2 vertices but are not sides. So you take this one, and that would be a diagonal. So from here to here, and I mean there's several diagonals, there are more than just one, but those are just examples of some. Now it says but are not sides. So you can connect these 2 vertices, but that's considered a side, okay? So that's why it says but, not the sides, okay? Exterior angles. So when you extend one of the sides, so here's a side, if you extend it out, that makes this exterior angle out here. Okay, so angles formed by a side and an extension of a side. Okay, then you have your interior angles, which of course is the inside of the angles, the inside angles. Okay, so here a polygon is convex if all the figures of the diagonal lie inside the figure. So if you make diagonals in here and they still lie inside the figures, these is a convex figure. Okay, so you can see if we connected these diagonals, they are inside the figure. The same with this one, they're inside the figure. But on this side, a concave, one of the sides caves in. That's why it's called concave. So if you notice right here, this little section here caves in. So because it caves in, when you connect the vertices, your diagonals are outside. So if we were to connect these vertices, our diagonals are outside. Or if we connect these vertices, our diagonal ends up outside. Okay, so if you notice, this kind of caves into the shape. That's why it's called concave, or the same with this one, it caves in. A regular polygon is a polygon with all sides congruent and all angles congruent. So pretty much when they say it's regular, that means all the sides and all the angles are the same. So here they show you a triangle, which is an equilateral. A quadrilateral where all the sides are the same, that would be considered a square. Okay, and so on. Let me just continue on. All right, so here it says tell whether each figure is a polygon. If it is a polygon, name it by the number of sides and classify it as convex or concave, regular, or irregular. So they were asking for a lot of stuff. So it's asking if it is a polygon. So we look at the first one. Yes, this is definitely a polygon. It says name it by the number of sides. Okay. So the number of sides here, it has 1, 2, 3, 4, 5. It has 5 sides. A 5-sided figure is considered a pentagon. Pentagon. Okay, and then it says classify it as convex or concave. So in this case, none of the sides collapse inside the figure, it doesn't cave in. So this would be considered convex. Convex. Okay, and then next it says regular or irregular. Okay, so if it's regular, all the sides are the same. As you can see, these little tally marks here show us that they're all the same. So this is considered a regular. Regular. And that's it. Okay. Looking at the next one here. So this one is a polygon. Let's go ahead and see how many sides it has. So it has 1, 2, 3, 4, 5, 6, 7 sides. So this is called a septagon or a heptagon, but we're not going to put both names. I'm just going to pick one. So septagon. We check to see, is this convex or concave? Well, this side caves into the figure. So this is concave. And then last is this regular or irregular? So this is going to consider irregular because none of the sides are the same, or not all the sides are the same. Okay, they all have to be the same to be regular. And that's it for that one. So we look at the next one, and then this one, if you see how this side right here is curved, so because it's curved, this is not a polygon. So not a polygon. I hate it because sometimes my pen just does not want to work with me. Polygon. I probably need to purchase a new pen. Polygon. All right. Interior angles of convex polygons. So divide the quadrilateral, the pentagon, and the hexagon into triangles. Triangles should not overlap. So pretty much here we have a quadrilateral. We can make a diagonal here going from this piece to this piece, and we create these two triangles as you can see. 1, 2, 1, and then this is another triangle too. We have a pentagon here. So we have the pentagon. If I go this way, that makes 1. I can go ahead and cut it right here. That makes a total of 1, 2, and 3 triangles. Okay. Next, we have a hexagon. So I'm going to go ahead and connect it here. I can make a connection here and a connection here. And that would make 1, 2, 3, and 4 triangles. Okay. So here, it says a triangle. A triangle is 3 sides. It has 1 triangle that is formed, and the sum of the interior angles is going to be 180 degrees. So here, a quadrilateral. With the quadrilateral, a quadrilateral has 4 sides. We can make a total of 2 triangles based off of what we did here. Because we have 2 triangles that we can make, we multiply 2 times 180, so that means the interior angles are going to equal 360, because 2 times 180 gives us 360. Then we have our pentagon. Our pentagon here has 5 sides. With those 5 sides, we can make a total of 3 triangles inside the pentagon. And so we're going to go ahead and do 3 times 180. And that gives me 3 times 180. That gives me 540. So 540 degrees. There. Okay, the next one, we have our hexagon. So with our hexagon has 6 sides. We made a total of 4 triangles based off of what we did here. So we're going to do 4 times 180. And that equals 4 times 180, 720 degrees. Okay, so then following the same pattern, okay, our next one, we have a heptagon, which is 7 sides. Okay, now if we notice this pattern here, if we have 3 sides, we can only make 1 triangle. If we have 4 sides, we can only make 2 triangles. If we have 5 sides, we can only make 3 triangles. If we have 6 sides, we can only make 4 triangles. So if we have 7 sides, we can only make 5 triangles. So then we do 5 times 180 equals 700. Oh, I didn't even do it in my calculator. 500 times 180. 5 times 180 gives me 900. Okay, if we have an octagon has 8 sides. That means we're going to be able to make a total of 6 triangles. So 6 times 180 is going to give me 1,080. Okay. So if we're trying to find the number of sides of any, or we have any number n here, which is an n-gon, that means that we have n number of sides. Okay, the number of triangles that we can form is you take the number of sides and subtract 2. Because remember, 8 minus 2 gives us 6. 7 minus 2 gives us 5. 6 minus 2 gives us 4. 5 minus 2 gives us 3. So that's the pattern here. You take your number of sides and you subtract 2. Okay, and then once you do that, you multiply that, whatever you get from there, and you multiply it times 180, and that is going to give you the sum of the angles. Okay, so here it says the sum of the measures of the interior angles of a polygon with n sides is n minus 2, and you take that and multiply it times 180. Okay, so here it says find the value of x in each polygon. So if we notice here, we have a 1, 2, 3, 4, 5-sided figure. So based off of this information, a 5-sided figure is a pentagon, and the sum of the angles is going to be 540. So the sum of these ones is going to give us 540 equals, I'm going to go ahead and add all these angles. So the x plus the 130 plus the 54 plus the 97. Kind of went into the other one. So I'm going to go ahead and add my like terms, which are the 130, the 54, plus the other 130, plus the 97. And that gives me 411. So we have 540 equals x plus 411. Now we're solving for x. So I'm going to go ahead and move this 411 to the other side by subtracting it. So 540 minus 411. Let's go ahead and figure out what that gives us. And that gives me 129 equals x. And that's it. The next one, now this one is a pentagon again. So we said the pentagon, the angles add up to 540. Wait, 1, 2, 3, 4, 5. Yes, 1, 2, 3, 4, 5. Let me just make sure. Yes, okay. And then from there, they tell us that this is a regular polygon. And by putting these little tally marks onto the figure, they show us that all the sides are the same. So that means all the angles are the same. So I'm going to go ahead and divide that by 5, and that'll tell me how much each angle is. So that tells me that each angle is 108 degrees. Okay. So here, let's look at the next one. This one has 1, 2, 3, 4, 5, 6. 6 sides. 1, 2, 3, 4, 5, 6. Yes. So here, 6-sided figure is a hexagon. The sum of the interior angles is going to be 720. So here I'm going to put 720 equals. We're going to go ahead and add all these up. So this is 90. This is 124. This is 150. This is 93. And this is 130. And then this is x. This one doesn't add up to anything because it is not like term. So I'm going to go ahead and add those up already in my calculator. Now, don't forget the 90 because they didn't put a number there, but we know that little box means that it is 90 degrees. So I'm going to go ahead and add them up together, and that gives me 587. Then to solve for x, we're going to subtract the 587 on both sides. That cancels. 720 minus 587 gives us 133 equals x. Okay, and the last one. This is a four-sided figure. So I know right off the top of my head that a four-sided figure is going to add up to 360 degrees. Okay, this is going to equal x plus, and then the x doesn't have anything to add up to, but we have 112, 71, and 48. So I am going to add those up together, and that gives me 231. Okay, so to solve for x, I'm going to go ahead and subtract this 231. This cancels. 360 minus 231, that gives me 129. And then degrees. All right, so here it says the sum of the measures of the interior angles of a convex polygon is given. Find the number of sides of the polygon. So now we're going a little bit backwards. So it tells us all the angles add up to 1080. So how many sides does this polygon have? So I'm going to go ahead and set that equal to my formula. It's n minus 2 times 180. Okay. So to solve for n, we're going to go ahead and divide both sides by the 180 first. So 1080 divided by 180, that gives me 6. So 6 equals n minus 2. And then to solve for n, I'm going to go ahead and add the 2 to both sides, and this cancels, and we end up getting 8 equals n. Okay, so that means this is an 8-sided figure, which is an octagon. Okay, the next one, they tell us that this is 2,160. So this is equal to n minus 2 times 180. Okay, I'm going to use a formula to find the number of sides. So just like we did on the previous problem, we're going to go ahead and get rid of that 180 by dividing both sides by 180. So 2160 divided by 180 gives me 12. So 12 equals n minus 2. And then to solve for n, I'm going to do the opposite and add 2. And that gives me 14 equals n. So that means that it has 14 sides, and this is considered a 14gon. Okay, this one says, and this is in terms of words, how many sides does a polygon have if the sum of the interior angles is 3,960? So I'm going to go ahead and take the 3,960 and set it equal to n minus 2 times 180. I'm going to go ahead and divide both sides by 180. Okay, this cancels. So 3,960 divided by 180 gives me 22. And then to solve for n, I'm going to go ahead and add 2 on both sides. This gives me 24 equals n. That's it. Okay, the next one says, how many sides does a regular polygon have if each interior angle measures 60 degrees? Okay, so this one's a little bit different. Okay, so it says how many sides, we're looking for how many sides of a regular polygon has if each one is 60 degrees. Okay, let's see. Where should we start? So for example here, we know that n minus 2 times 180 is going to give me the total number of sides, right? Okay, and then we don't know what the total is here of all the angles together. But then, so whatever we have here, we know that if we divide it by the number of sides, if we take the whole thing and we divide it by the number of sides, that's going to give me 60 degrees. Okay, and then from there, we're going to go ahead and solve for n. So what I'm going to do is I'm going to go ahead and move this n to the top of the 60, pretty much like I'm going to cross multiply. Okay, so we get n minus 2 times 180 equals 60 times n. Okay, I'm going to go ahead and distribute this 180 to in each one. So we have 180n minus 360 equals 60n. Okay, and then from there, Let's see. Let's go ahead and move the 180 end to the other side, and we do that by subtracting. So I'm going to go ahead and move it on to the other side with the other end. Cancels here. We get negative 360 equals, I'm going to do 60 minus 80. That gives me negative 120. And then last, I am going to take the negative 120 and I divide both sides by negative 120, and that gives me 3. So that means that this figure is a triangle that each angle is 60 degrees. And that's it. Okay, so here it says find the measure of the exterior angles of a polygon. So for example, here we see that this is a 90-degree angle, and then this is a straight angle. The interior angle plus the exterior angle should add up to 180. So then 90 plus 90 gives us 180. So that means each of these is 90, 90, and 90. Okay. And then for the triangle, remember here's the extension. So because this is an equilateral triangle, each interior angle is 60. Okay, so the exterior angle, if we do 180 minus 60, that gives us 120. So each one is 120. 120 and 120. So it says the sum of the exterior angles in each polygon. Well, if I add 90 plus 90 plus 90 plus 90, I plug that in my calculator, that gives me 360. On this one, if I do 120 plus 120 plus 120, that also gives me 360. So coincidentally, it doesn't matter what size your polygon is, whether it has 3 sides, whether it has 20 sides, whether it has 150 sides, the sum of the exterior angles will always be 360. Okay? So it says the sum of the measure of the exterior angles of a polygon, one at each vertex, is 360. Okay, so here it says find the value of x in each polygon. So the measure of the exterior angles all add up to 360. So I'm going to put here 360 equals, and I'm going to add these up together. So we have a 65, a 40, a 50, a 50, a 50, and a 40. So I'm going to go ahead and put that in my calculator real quick. That gives me 295. Okay, plus the x also. We still have to add this x here, but it just doesn't have anything to combine with. So in that case, I'm going to go ahead and solve for x by subtracting the 295. This cancels, so 360 minus 295 equals 65 equals x. And that's it, so 65 degrees. Here they want us to find x. So this is a 1, 2, 3, 4, 5, 6, 7, 8. This is an 8-sided figure. It's an octagon. So because all the angles in this exterior angle should add up to 360. If I divide that by 8, that's going to give me each exterior angle because it has 8 sides or 8 exterior angles. So 360 divided by 8, that gives me 45. Okay, so here it says a measure of an exterior angle in a regular polygon given, find the number of sides. So if the exterior angle of a regular polygon is 72 degrees, we want to know, okay, well, how many sides does it have? So that's what we're trying to figure out. So I'm going to go ahead and take the 360 and I'm going to divide it by 72. Okay, so 360 divided by 72 is going to give me 5. That means this is a pentagon or a 5-sided figure. So either or. Okay, now we have 30, so we take the 360 and we divide it by 30. So 360 divided by 30, that gives me 12. So that means we have a 12-sided figure, or what we call as a dodecagon. Okay. And this last one is saying, find the value of n in the pentagon PQRST. So it is a pentagon. It has 5 sides and actually gives us the exterior angle. So 5n, 4n, 3n, 2n, and n. So when we add all these up, 5, 9, 10, 11, 12, 13, 14, 15, I believe. So 15n. We add them all up, and the sum of the exterior angles should give us 360. We divide by 15, and we get x, not x. We have n equals 360 divided by 15. That gives us 24. Okay, so they're asking us for the measure of angle P. Here's angle P. It's 3 times n, and we know n is 24, so 3 times 24 is 72 degrees. And it's asking us for the measure of angle Q. Here's angle Q. That is 4 times n, and we know that n is 24, so 4 times 24 gives us 96. Then they ask us for the measure of angle R. Here's angle R. R is 5 times n. Well, we know n is 24, so 5 times 24 is 120. And then we have the measure of angle S. So we find angle S. Here's angle S, which is just n, and we know n is equal to 24 degrees. And then last, the measure of angle T. Here's angle T, which is 2 times n, and we know n is 24, so 2 times 24 gives us 48 degrees. And that's it for me, guys. If you guys have any questions, go ahead and leave it in the comments. Thank you, guys. Bye.